Let's take a look at another example whereby this time, instead of having an odd number of data points, we're going to have an even number. And what I'm going to do is I'm going to take the same set of data, but I'm going to instead add 158 to it. So the first step then would be to put those data points in order again from smallest to largest so that we can find the median easily. So we have 24, 43, 52, 61, 67, 72, 78, 83, and maybe while I'm doing this, maybe you can predict where we might put some division lines for Q1, Q2, Q3 to break this into 4 equal pieces. Why don't you take a moment, you can even pause the video if you like, and see if you could do that. You can unpause it then and see if you got it right. When we count in from the ends, we discover that we end up with there being 2 data points that end up being in the middle. We end up with 72 and 78. So we know that there needs to be a division line here for Q2, but what is the value of Q2? Well, what we're going to do is we're going to take the average of these two values, or what value is in the middle. So we can add 72 and 78 together and divide by 2, or we can recognize that 75 would be in the middle, 3 away from 78 and 3 away from 72. Now, in order to divide up the rest of the data, we see there are 6 points here on the left that we want to put evenly into 2 categories. So a division line will have to go here. This is where Q1 would be. What would the value of Q1 be? Well, again, we're going to take the average between 52 and 61. Maybe that one's not as easily mental mathed, if you will. So if it's not, all you have to do is take 52 plus 61 and divide it by 2, find its average, and you'll find out that 56.5 is where it's at. Let's do a similar thing on the other side of the median, realizing that the middle will be here, and we're going to have to take the average of those 2 values to be our Q3 value. So, can you anticipate where the middle is? Well, I think 89 would be in the middle. It's 2 away from 87 and 2 away from 91. And so there we have our Q1, Q2, and Q3 values. From this point, we can create the box and whisker plot. So, again, I'm going to take a moment to draw what you have in your notes. And I'm going to do a similar scale. I'm going to allow every vertical line to be worth 5. So you could go ahead and label yours in as well. Labeling every other line being worth 5. And this time I'm going to choose to go from 0 all the way up to 160. You'll see why in a few moments, but I just want to make sure that on my box and whisker plot, every key feature can be shown, and I'm not going to be running out of room or leaving anything out. Now, I know my lines aren't perfect, but you'll get the idea. All right, let's start labeling some key features. Let's start in the middle and then work outward. So 75 for Q2 would be located right on this line right here. Okay, we can do Q1 and Q3 as well. 56.5 will be just past the 55 mark. I think I will label this one because it's going to be hard to know that it's a half value, even if I did have perfect squares. And over here, 89 would be just before 90. And then I could draw my box. And again, I'm going to leave the colors in just so that you can see where they came from. But you would draw the box around the outside of Q1 to Q3, and you would also draw a line in the middle for where the median is, where Q2 is. Now, it's time to see if 24 or 158 are outliers in this scenario. So let's first of all review how to find IQR. It is the difference between Q3 and Q1. So we can do 89 minus 56.5. Notice our values of Q3 and Q1 and even Q2 have changed by adding that extra data point. and we end up with an IQR of 32.5. Similarly, the SIQR would be half of the IQR, or 32.5 divided by 2, which would be 16.25. So let's do a lower outlier calculation to see if 24 should be included. Again, we're going to take Q1 and subtract 1.5 times the interquartile range. So that would be 56.5 minus 1.5 times 32.5, and we end up with a value of 7.75. So that means 7.75, which would be down here somewhere, is the absolute limit by which the data points can no longer be considered to be part of the set. 24 meets that, no problem. So let's draw in our low range. Let's put 24 right here, and again, if you want to label it, you could. And let's make the whisker at the low end. Lastly, we need to see how the upper outlier is. Quick calculation. This time we're going to do Q3 plus 1.5 IQRs. Our Q3 value was 89. Our IQR value is 32.5. And when we do the calculation, we see that we get 137.75. So that means the upper range within this data set, in order not to have too big of a spread, should be 137. Our data point here of 158 well exceeds that. Okay? So therefore we would say, therefore, 158 is an outlier in this data set, and we would not include it in the box and whisker plot, or would we? Well, actually, there is a way to include it, but to make it clear that it is an outlier. So this means that 94 is going to be the upper limit of our range for this data set. So we go to 94, it's going to be very, very close, and we can finish the whisker. And to show that 158 is an outlier, we're going to leave it as a disjointed point, all by itself. 158, boom, just sitting up there. And that's how you can create a box and whisker plot to show the measures of spread when you deem that the median is the best way for communicating the central measure for a data set.